So we are in question number 4. Question number 4 says, or 4a says, find the general solution of this differential equation. So as usual, to solve the differential equation, I'm going to try and see if I could separate the variables. So I could use the separation of variables method to solve the differential equation. Now if that's not possible, I will try and rewrite, since it's a first order linear equation, I'll rewrite it as a standard linear equation and see if I could use the integrating factor method of solving linear equations. So let me first start by seeing if I can separate the variables. So what you have is the p dt equals, when we bring this to the other side, you have p plus 4t minus 2, then minus 2tp. Now this is going to be the same thing as p plus 40, so we could just bring the negative, this is negative 2tp, then this is plus 40 minus 2. So what you have is p is common here, so we have p into 1 minus 2t. Then here also you have 2 is common, that's 2 into 2t minus 1. So this is the same thing as p into 1 minus 2t. So in an A, to write this, what I have in this bracket here, to be similar to what I have here, so it's just a matter of putting a negative sign here, and then they are going to be the same thing. So now we have these two terms to be equal, so they are common to each other. So I could bring them, I could factor that out. So you have 1 minus 2t into p minus 2. That's what I have. So and what we have here is the t equals this. So looking at this, it's quite easy for me to see that I have been able to separate the variables here. This is just in terms of p, and this is a function of t only. So I could bring my p's to this side and then my dt to that side. So let's see how we do that. We have the p over p negative 2 equals 1 minus 2t dt. So the next thing is we integrate both sides. So integrating both sides, so this is going to be the ln of p minus 2 equals, is going to be t minus t squared, then plus our arbitrary constant. So when you simplify that, we're going to skip some steps here. This is going to be p minus 2 equals e to the power t minus t squared dot b. I've skipped some steps there, so this is something as p equals 2 plus b e to the power t minus negative t squared. Now this is the general solution of this differential equation. So part B says, find the largest interval over which the general solution is defined. Now to find the largest interval over which the general solution is defined is actually, or it could also mean telling you to find the interval of definition. That could be another way of rewriting that. So to find this, so if you look closely, you observe I could rewrite this as a linear equation. In standard form, let me write what we have above there to be, we have the p dt plus 2tp equals p plus 4t negative 2. So when I bring this p to this side, so what we have is the p dt plus 2tp minus p equals 4t minus 2. So p is common here, so you have the p dt plus 2t minus 1 into p equals 4t minus 2. Now you recall that for a linear equation in standard form, say the p dt plus p of yt equals g of y. Now the general or the interval of definition of the solution of this differential equation here is actually the interval over which p of y and g of y are continuous. Over which p of y and g of y are continuous. P of y and g of y are continuous. So in other words, when you have a differential equation, a linear first order differential equation, the first thing is write it in standard form. When it's in standard form, then you go ahead and check what you have here, the coefficients, and then the forcing function here, what you have here. Whatever interval over which the two of them are simultaneously continuous on, now that is going to be your interval of definition. Now looking at what we have here, our p of y is representing 2t minus 1. So this is 2t minus 1. And then our g of y is 4t minus 2. So now this as a function here is continuous, or is continuous for all reals, all real numbers, that is on this interval here. And then similarly 40 minus 2 is also continuous for all reals. Actually, if you want to look at it the other way, they are polynomials, they are polynomial functions of t. So and polynomial functions, they are continuous on the set of all real numbers. So if you want to look at it that way, it's another way of looking at it. It's defined. The limit as t tends to any point in this domain equals the function value at that point. So either which way, this, that is negative infinity to infinity, is your interval of definition. Interval of definition. And this was what they told you to find. Okay, that completes that. Now for the last part, the same differential equation, you're told to find or to check if there is any transient term in the general solution. So actually, what I mean by transient term is, in a general solution, of all the terms of the differential of the general solution, like you have here, we have 3 terms. Is there any of them that contains a transient term? That is, as the independent variable tends to infinity, is there any of them that actually diminishes to 0? That is what you need to check. Now if you look at this, this is 2, is actually constant, so it's not diminishing as t tends to infinity. But if you look at what we have here, now what we have here is the same thing as, this is p equals 2 plus b e to the power t times e to the power negative t squared. Actually, as t tends to infinity, now e to the power t also tends to infinity. But this, which is e to the power negative t squared, tends to 0. Now you might begin to look or get confused that, so which am I going to choose? Now what you need to look at is the t that we have here, and what we have here is t squared. So this one approaches 0 faster. Approaches 0 faster than this one would approach infinity. So in the long run, this main man here will take charge or will be in control of the term. So we'll be in control of the term. So even though this is increasing to infinity, this one here tends to 0 faster. So this is going to be our transient term. So now they ask, is there any transient term in the general solution? Yes, there is. And then what is it? It is b e to the power t minus t squared. Why? Because this tends to 0.